Hello everyone. In this lesson, let's learn the technology and key points of mechanical transmission assembly. We will study from three parts: synchronous belt drive assembly, chain drive assembly, and gear drive assembly. Through this lesson, I hope everyone can master the basic principles of transmission technology, understand the application of different transmission methods in mechanical equipment, and be able to correctly select transmission types and specifications according to the design requirements of the transmission system, reasonably configure relevant components, and complete the design and debugging of the transmission system. At the same time, we cultivate everyone's rigorous working attitude in engineering practice, enhance their ability to solve practical engineering problems, and stimulate everyone's thinking of innovation and optimization in the field of transmission technology. First of all, please watch a video on the slide.
大家快听，这就是差速器异响的声音。如果你的爱车也出现这种声音，就要尽快维修了，因为里面的轴承或者齿轮已经磨损，如果时间拖久了，就会把齿轮或者轴承都打烂，严重就要整个电机都换掉。原本只要花2-3千就可以，现在就变成1万多才能修好。
Well, we have roughly finished watching the video. Then everyone, behind these shocking failures, there is a common culprit: assembly errors. If the gear is misaligned by 0.1 millimeters, why can the 100-ton machine tool be paralyzed? Why do you need special tensioning tools for seemingly simple chain installation? If you are given a set of transmission parts, can you make them cooperate tacitly? What fatal details are hidden in assembly technology? Next, we will further study the assembly technology of mechanical transmission and its key points around these issues. First, let's learn the assembly of synchronous belt drive. The first point is about the choice of pulley retaining ring. In order to ensure the normal operation of the synchronous belt drive, the pulley retaining ring can be selected according to the following conditions. In a two-shaft drive, one of the two pulleys must have retaining rings on both sides, or one retaining ring on different sides of the two pulleys. In transmissions where the center distance exceeds 8 times the diameter of the small pulley, there should be retaining rings on both sides of both pulleys. In a vertical axis drive, one of the pulleys should have retaining rings on both sides, while in the system the other pulleys only have retaining rings on the bottom side. In multi-axis drives, 2 retaining rings should be ensured for every other pulley, or 1 retaining ring around the opposite side of each pulley of the system. The second point is about the requirements for pulley installation. When installing the pulley, attention must be paid to the parallelism of the axis of the pulley, so that the transmission center plane of each pulley is located in the same plane, so as to prevent the belt side from being pressed on the retaining ring due to the deflection of the pulley, resulting in aggravated wear of the belt side, and even the belt being cut off by the retaining ring. Therefore, when the pulley deflects, it must be adjusted. Adjust the deflection angle to the allowable range. While ensuring the alignment of the pulley, the stiffness of the transmission frame and shaft should be ensured. When using pulleys, the corrosion on the pulleys must be removed to avoid premature wear of the timing belt. The timing belt must be installed with proper tension. If the tension force of the belt is too small, it is easy to cause the belt teeth to jump out of the tooth grooves of the pulley, climbing teeth, when it is started frequently, and there is impact load. If the belt tension is too high, it is easy to reduce the life of the belt. Tensioning of the belt can be achieved by changing the gear center distance. The appropriate degree of tension can be checked by adding weight at the midpoint of the span between the two pulleys, which depends on the type, width, and length of the belt. The tensioning wheel can be used in the following situations. A. As a method of belt tensioning when the center distance cannot be adjusted. B. In larger speed ratio transmission, increase the wrapping angle of small pulley. Installation method of tensioning wheel. Depending on the purpose of the tensioner wheel, there are 2 installation methods. A. Install on the inside for belt tensioning. The tensioner should adopt a toothed pulley. when the number of teeth of the tensioner is greater than the minimum number of teeth of the pulley. In order to avoid reduction of number of meshing teeth, the tensioner should be installed on the loose side. B. Install on the outside, used to increase the force and retard the wrapping angle of the wheel. The tensioner can adopt a flat pulley with no protrusion in the middle. Its diameter is the diameter of the pulley with the minimum number of teeth, and it is installed on the loose edge so that the belt will not be excessively bent. After learning the assembly of synchronous belt drive, let's learn the assembly of chain drive. The first is the technical requirements of assembly. 1. The axis of the sprocket must be parallel. Non-parallel axes will aggravate the wear of the chain and sprocket, reduce the transmission stability, and increase the noise. Generally, the parallelism error is checked by measuring the size, which is generally less than 0.3/500 millimeters. 2. The axial offset of the two sprockets must be within the required range. The offset depends on the center distance. Generally, when the center distance is less than 500 millimeters, the allowable offset is within 1 millimeter. When the center distance is greater than 500 millimeters, the allowable offset is within 2 millimeters. The ruler method can be used for inspection. As shown in the figure, when the center distance is large, the pull wire method can be used for inspection. 3. After the sprocket is fixed on the shaft, the runout must meet the requirements, and its relevant allowable values are shown in Table 4.3 and Table 4.4. The chain sag should be proper. The sag is F/L. F is the sag amount, in millimeter, and L is the center distance, in millimeter. The allowable sag is generally 2%, in order to reduce the vibration and unchain phenomenon of chain drive. 4. The fit between the sprocket hole and the shaft usually adopts H7/K6 transition fit. This fit method can work normally under appropriate interference while ensuring a certain clearance. The specific fit selection should be decided according to the actual use requirements of the hole and shaft to ensure the best transmission effect and long-term stability. 5. The opening of the connector clip of the chain should face the side opposite to the movement direction of the chain. This design is to prevent the clip from falling off or loosening due to the pulling force of the chain during operation, and to avoid chain release accidents. When the chain is moving, the clip opening may be subject to greater friction and pulling force towards the direction of movement, increasing the risk of clip falling off. Therefore, ensuring that the opening orientation of the clip is opposite to the movement direction, the pulling force of the chain can be used to enhance the fixing effect of the clip, thereby improving the safety and stability of the chain and reducing the probability of failure and accident. The assembly method of the sprocket is basically the same as that of the pulley. As shown in the figure, the fixing method of the sprocket on the shaft is to connect it with the sprocket and then fix it with the tightening bolt. After learning the first two drive assemblies, we will learn the last gear drive assembly. The first knowledge point is general technical specifications for gear drive assembly. The fit of the gear to the shaft must meet the design requirements. The parallelism error of the two axes of the gear should be within the allowable range. The gear pair center distance deviation, F, must be controlled. The flank backlash of the gear pair after assembly should be controlled within the specified range. Ensure the gear pair contact the pattern while it's meshing. The second point is the method for assembly of gear drive structure. The first is the assembly method of axially fixed gears. It is divided into two types. One is to transmit power through interference fit. This axial fixed gear needs to be pressed in with a press during assembly, and the interference needs to be controlled. When the interference is large, it is also necessary to use the hot jacket method for assembly. That is, the gear is heated to a certain temperature, and the shaft is at room temperature. The thermal expansion method is used to reduce the assembly interference, and then press it in. When the temperature of the gear drops, it can be wrapped tightly on the shaft, or the gear can be cold treated at normal temperature to reduce the temperature of the shaft, shrink the shaft, and then assemble it and press it in. When the temperature rises to normal temperature, the gear is not easy to remove after assembly by this press-in method. The other is to use key to transmit torque, and its fit interference is very small. The interference is less than 0.01 to 0.015 millimeters, or it can be a transition fit. This kind of assembly can also be assembled by hot jacket method and cold treatment method, and it can be assembled as long as it is easy to put in. Of course, the most common assembly is the direct assembly method. The interference is less than 0.05 to 0.008 millimeters, or there is a small clearance, in which the gear is directly pressed into the mating shaft by a press, or directly knocked into the mating shaft. This method requires measuring the values of the hole and shaft with a micrometer before assembly, and calculate the interference to be less than 0.005 millimeters. The characteristic of this method assembly is that the assembled parts can be disassembled. The second is the axial sliding gear assembly method. Some gears need to exchange meshing states during use to change the rotating speed and need to slide in the axial direction. The matching of such gears adopts clearance fit. During assembly, it is also necessary to pay attention to the need for axial positioning after assembly, and the assembly method is relatively simple. As shown in the figure, it is the axial positioning device. Finally, the inspection of the backlash of the gear pair. The measurement methods of gear pair backlash include single point method, single mesh method, and double mesh method. The single point method measures the installed gear pair on the box. It can also be measured on the rolling testing machine. It is a common measurement method in actual testing. The single meshing method is measured by gear type, single-sided meshing checker, and transmission measuring instrument. Double meshing method uses the double-sided meshing checker. The simplest commonly used method is to measure the side clearance. The lead pressing method is to place more than 2 lead wires on the pinion along the tooth width. The diameter of the lead wires is selected according to the size of the clearance. Generally, it should not exceed 3 tons of the side clearance. The length of the lead wire is generally 3 to 5 teeth, and it is glued to the teeth with dry oil. After the lead wire is placed, rotate the gear evenly, and the lead wire is squashed. The smaller thickness is the working backlash. The largest thickness is the tooth tip backlash, and the larger thickness is the non-working backlash. Its thickness can be measured with a micrometer. The sum of the working backlash and non-working backlash of the tooth is the tooth backlash. This method is simple and applicable. The measurement results are relatively accurate, and it is widely used. As shown in the figure, it's the measuring method of the lead pressure method. Finally, there are issues that should be paid attention to when assembling gears. 1. Before assembly, inspect and check the relevant parts of the gear transmission device, especially the repaired and replaced gears. It is best to replace the gear pairs in pairs. 2. Carry out necessary trimming on relevant parts, remove defects such as flashes, burrs and bruises, and thoroughly clean all parts. 3. During assembly, the matching of gear holes with shafts, single keys, or splines must meet the requirements. When adjusting, pay attention to the meshing trajectory of a pair of old gears or new and old gears. Generally, the 2 gears should be axially centered. The shift positions of each stage of the slip shift gear should be as centered as possible, and the shift device should be stable and reliable. 4. The gear installed on the shaft cannot be skewed or deformed. 4 multi-stage transmission gears. The transmission shafts of each stage should be assembled and adjusted to rotate flexibly and have no obvious axial movement. Additional fasteners such as set screws, locking wires, nuts, spring retaining rings, pins, etc. should be installed safely to prevent loosening during operation. 5. Check the tooth side clearance and contact spots after assembly. Contact spot is the most direct sign and final comprehensive reflection of repair and assembly. When it fails to meet the requirements, it is necessary to analyze and find out the reasons for repair. Carry out necessary trial runs and break-in procedures. Adjust and repair problems in time if any problems are found. Pay attention to appropriate running-in specifications when running. Generally, the Deere transmission can be called the Deere transmission of good quality only if it runs smoothly, has strong bearing capacity, and does not fail within the predetermined service period. In this lesson, we learned about mechanical transmission assembly technology and key points. Through courseware demonstration and in-depth thinking, you not only mastered relevant skills, but also deeply realize the importance of sense of responsibility. I hope you can continue to carry forward this spirit in your future study and work, and make greater contributions to China's engineering and technology undertakings. Finally, please think about this course and complete the following exercises, aiming at consolidating the knowledge points you have learned today and further deepening your understanding. This lesson ends here. See you next time.